Hello all, welcome to my channel. I'm ready with a new video. This is a continuation of the Spark series that we are doing. In this video, we will be going through a Spark phenomenon called spill, which is nothing but writing of the data that is present in the memory. And when memory is not enough, when then it's written to disk. That's what a spill is. To and this is a process using which Spark tries to be more reliable in a sense. It doesn't throw away the errors, throw away an out of memory error directly. In some cases it will still so, but this spill is the mechanism through which it tries to accommodate certain aspects of data which is not fitting in memory. So let's get started in this video. So as this uh, basic thing is when Spark does the data in process, so data processing in memory, and as we know, everything doesn't fit in memory, and that's the time when it will try to uh, spill into the disk, and that's where the moment it's tried to spill to a disk, there will be disk IO serialization overhead and stuff like that. So if you know, executor memory that we have is divided into two parts, right? There is one execution memory and then there is a storage memory. And so storage memory is used for any cached objects. So for example, if we are trying to do df.cache and that caching is happening, so that cache resides in this storage memory. But what if that the memory that we need for storing the data or caching the data is greater than uh, the size of the memory that is available to that executor? At that time, if for example, we have options of choosing cache storage level, if we select memory and disk with SERDE, so at that time the extra things which cannot be fit in memory will be spilled to disk. Same goes with the other part when we have execution memory. If let's say we have created so some objects in memory, for example, we are doing a sorting, and during the sort, if that to do the full sort, if things doesn't fit in the memory that is allocated for the execution, that also will get spilled to the disk. So these are the different things which cause uh, sorry, not this one. This is a note that when we do a disk splitting, the in partition order is lost because it's not same way as what was present in the memory. And reasons for a spill. So there are multiple reasons why a spill can happen. One is skew data. So let's say some partitions are processing more data than the other ones, and that partition, because memory we decide while launching the job for executors, and let's say one executor is processing 1,000 records, and other executor of the same stage is processing, let's say, 3,000 records. So that it's common to for us to know that okay, if the data there is a data skew and things will not fit in memory, it will be spilled. Let's say then another one is where when we are doing a shuffle. So let's say as in my previous video as well on shuffle, we discussed this that during a shuffle the uh, disk write is involved. So this that also is an spill when we are doing a join or a cross join, suddenly because we will have a lot more records coming to one particular executor. So at that time also there will be a disk involved. External sort, again, as I mentioned, let's say we are doing a sort merge join. So before a merge happens, there is a sort involved, and that sort can be an external sort. And the moment it is an external sort, it will write to a disk. Then we have, let's say we are doing a cache, as I mentioned, RDD cache or data frame cache that can be spilled to the disk. Broadcast can also cause us this broadcast is not strictly for the broadcast join. This broadcast is for anything else as well. Let's say you are broadcasting some variable and that variable size is bigger, that also and doesn't fit in memory of the executor, it will be spilled to disk. UDFs, let's say if they are doing an explode, that might result in an spill on a disk. As I mentioned, explode is also here. Uh, then if we have, let's say, smaller number of shuffle partitions, equal to shuffle partition, this is a flag which sets how many partitions will be created after a white transformation, or a transformation which results in a different number of partitions later on, for example group by. So by default it is set to 200, and let's say if we have more than 200 unique keys, so some executors will land up with more resources, and the other way is, let's say if we have a skew, that may also cause this one executor processing more data, and the moment one executor processes more data, it will cause more spill to the disk. Uh, this is also one. Let's say if we have set max partition bytes to a very high number, let's say generally it is recommended to be set at 128 or 256 MB. This is coming from the block SDFS block size. Based on that, it is recommended for 128 and 256. People also set it to higher numbers. You can set it to 1 GB as well. But when you are setting that to 1 GB, be mindful that if your executors are not having enough memory, it will write to disk. Then again, spill will happen. Okay, in our job page of the live UI or the history server UI of a particular job, we will see this tab is there. In the executors tab, we can see spill happening from each executor. So there are two types of spill which they denote. One is spill on memory. Uh, this is the data which will be spilled to the disk, but before getting a spill to the disk, it says, okay, what was the footprint of that particular data in memory, and what is the, once it is written to disk, what is the size? That becomes the next part, which is spilled to the disk. So this is all about spill. There is challenges, and there are, what are the solutions that we can use to reduce the spill. So one is that all the problems that we have mentioned is, if we can tackle individually, we can reduce the spill. Like instead of in case of skew, we can repartition and create more better partitioned layout. Unnecessary cache we can avoid. We can do joins which are more memory, which has a lesser memory footprint rather than having more. For example, shuffle hash join will create a hash, and that hash is created in memory, and if that doesn't fit in the memory, it will write to disk. Also, other options are to use sort merge join, so that doesn't use memory. So but there is a trade-off between that as well, that sorting will cause some spilling if we have larger sorts. So yes, we have to, for our use case, we can try out both thing and see which one works better, and then setting it to the right value. There is one thing that I will tell you is that if you are having large number of partitions, and let's say you are handling with, let's say, 1800 1900 partitions, it's better to switch it to 2001, because there are two different algorithms that comes kicks in. There are two different algorithms, one for partitions lesser than 2000, another for partitions greater than 2000. So if you are nearing that 2000 range, make it 2001 so that it uses the partition algorithm which is more suited for higher number of partitions. Uh, Setting the right value of max partition by doing a repartitioning at the right time will also reduce in spill. Uh, and there's one very interesting question that people generally ask, and this is one interview questions as well, which is asked quite often and this is, it's a tricky question. Tricky in a sense, it tests whether you understand the basic phenomenon or not. So the question is like, if spill is there, then why we get the OM? So that's one question that comes, and it is something which uh, one thing that we have to understand. And the reason we do is that, first of all, that not all memory objects are splittable. For example, let's say uh, if we have something, let's say we have a JSON object, we can't do a split in between, right? Either the whole block is read, or whole JSON is read, or it's not read. So we can't split a JSON. So if we have, let's say, some objects in memory which we cannot split, so either the whole thing is has to be written into the disk, or it will try to see whether I can hold it in memory or not. If that object and then that object needs to completely fit into the memory, right? If that is not happening, they will still throw an error, and that's where we will get an out of memory error. Uh, and also the point is, let's say if we can spill to disk, but when we are reading back, we want that object completely into the memory for processing, right? At that time, if that object is not splittable, so we can't process in parts. And let's say if it exceeds the memory that is allocated or that is available in the executor memory at that time, and we have already crossed that eviction threshold as well, then there is no way for Spark to process, and that's where we get an OOM. So these are these are few things, and other one is that not the one is the spill is done by JVM, and Spark overhead memory that we get is the always the off-heap memory that is coming into picture, and that's where we see OOM because of that as well. So there are different reasons why we see OOM, although we have spill in picture. So yeah, this was it for this video. Hope it was helpful. Thanks.